Most AI engineers don't think about inference costs until they're staring at a 5-figure cloud bill and scrambling to explain it to their CTO. The uncomfortable reality is that teams spend weeks debating which frontier model to use, running elaborate benchmarks, and the model choice ends up being almost irrelevant to the actual cost problem. The real money is being burned by architecture decisions made before a single token is ever generated. Here's a counterintuitive truth that separates senior AI engineers from everyone else. The LLM itself is rarely the most expensive part of your system once you account for the full picture. When you factor in redundant calls, oversized models handling trivial tasks, and missed caching opportunities, teams routinely waste 10 times more than the raw per token cost suggests. The model is the engine, but your architecture determines how many times you needlessly rev it. A 70 billion parameter model classifying customer intent into 5 buckets is like hiring a neurosurgeon to take your temperature. A smaller fine-tuned model running at a fraction of the cost will match or exceed performance on narrow, well-defined tasks because it's been specifically trained for that exact job. The engineering discipline here is ruthless task decomposition. Breaking your pipeline into discrete jobs and asking honestly what each one actually requires in terms of reasoning power. Exact match caching is table stakes, but semantic caching is where the real leverage lives. If your system has answered 400 variations of, "How do I reset my password today?" every new variation should be hitting a cache, not generating a fresh inference call. Tools like vector-based similarity search let you define a confidence threshold. If an incoming query is semantically close enough to a previous one, you serve the cached response instantly at near zero cost. In high-traffic consumer applications, this single change can reduce inference volume by 30 to 50%. Engineering teams consistently overestimate how many of their AI workloads actually need to be real-time. Document summarization, report generation, content tagging, embeddings computation, these feel urgent because they're in the critical path of a user-facing feature. But with smart queue design, users rarely notice a sub-second delay becoming a 2-second one. Batching these jobs together and processing them in windows rather than one by one can cut your per-unit inference cost in half. And most major inference providers offer explicit batch pricing tiers that make this even more dramatic. Some of the biggest inference cost savings come from the most unglamorous realization. This task never needed a language model in the first place. Extracting structured data from predictable formats, routing requests based on keyword patterns, validating input against a known schema, these are jobs that regex, rule engines, and lookup tables have handled reliably for decades. The pattern matching power of an LLM becomes waste when the pattern is already fully known and deterministic. Spending 20 minutes writing a regular expression instead of an API call can save thousands of dollars monthly at scale. The most useful mental shift for AI cost optimization is borrowed directly from back-end engineering. No experienced database engineer fires a query every time something might need answering. They think about indexes, caching layers, query plans, and connection pooling. An LLM call deserves exactly the same rigor. Why am I making this call? Do I already have this answer somewhere? Is this the right model for this read pattern? And could this be deferred? Teams that apply this discipline discover that a significant portion of their inference calls are the equivalent of running a full table scan when an indexed lookup would do. Every AI team moves through a predictable arc. The prompt gets you to a working demo, good model selection gets you to a convincing pilot, but only architectural discipline gets you to something that survives real production traffic without destroying your unit economics. The teams that win long-term are the ones who start mapping their inference calls the same way they'd audit their database queries, finding the redundant ones, the oversized ones, the ones that should be async. You will cut your infrastructure bill substantially before you ever need to negotiate better API pricing, and you'll do it while making your system faster and more reliable.